So we're going to be solving for this homogeneous differential equation right here. So we're going to say dy over dx is equal to y minus x over y plus x. So what we basically do is we're going to set y over x to a variable called v. So if you multiply x by both sides, that's y equals vx, right? So we're going to be making a substitution here. So it just becomes vx minus x over vx plus x. And if you factor x, both the numerator and denominator, you get this. And then we could cancel out the x's. So it just becomes v minus 1 over v plus 1. Alright, so that's not that bad. And how are we going to signify dy over dx? So how we do this is knowing that this is v over vx, we can do the derivative of this, and this is constant for all cases. So what we do is we do the chain rule here. So first we're going to do, not chain rule, product rule. So we're going to say this is v times the derivative of x, which is 1, plus the derivative of v. So that's dv over dx. It's going to just be 1 dv over dx, because that's implicit differentiation times x. So if I just rearrange this a bit, you say x dv over dx plus v, and that's equal to dy over dx. And this is constant for all, so it's good to just memorize that. So I'm going to say x dv over dx plus v is equal to v minus 1 over v plus 1, then minus the v on both sides, so we're going to get dx is equal to v minus 1 over v plus 1 minus v. So we are going to make this into fractional form, so we're going to say that this is v minus 1 over v plus 1 minus, we want to get common denominators, so we're going to do v plus 1 here, and we're going to do v times v plus 1, so that's going to be v squared plus v, yeah. So this just becomes on the top negative 1 minus v squared over v plus 1. Alright, that's cool. So that is equal, so negative 1 minus v squared over v plus 1 is equal to x dv over dx. Now we're going to separate the variables, so I'm going to divide x on both sides, and we're going to times dx on both sides, and we're going to also divide by negative 1 minus v squared over v plus 1 on both sides. So what this becomes is just v plus 1 over, so I'm going to call this negative 1 plus v, I'm going to do like this, just because we know that this is the exact same thing as v plus 1 over negative 1 minus v squared. So we could just put the bottom here, and that's equal to 1 over x dx. So it should say dv. We're going to integrate with respect to its corresponding variables, dv on the left and v on the left and x on the right. So this one, you know, of course, is ln of x. Yeah, ln of x plus c. Technically, it's absolute value. Aren't going to really matters in this case. So, and we're only going to keep a c on this side. I mean, anyway, even if you get a c on this side, a c and c, that will just cancel out to a c as well, because a c minus a c, a constant minus a constant is another constant. So we don't need to worry about the c on this side. So we're going to integrate this one. So this is, so I'm just going to move this here. So this is just equal to integral v plus 1 over 1 plus v squared dv. Alright. So what is this equal to? So we're going to separate this into two different partial fractions, plus 1 over v squared dv, and this becomes much easier. This one, if you remember your trig 7, you remember your inverse trig, the derivatives of inverse trig functions, you know that this, the antiderivative of this is just going to be arctan of v, and then this one we know that, so this one we can use u sub. So I'm going to say that if I set 1 plus v squared equal to u, du is equal to 2v dv. Alright, so we're going to say that half of du over u, so we're going to find the integral of this, so that's just going to be negative half of the integral of 1 over u du, and that's just going to equal negative half times ln of u, and we don't really, like I said in the beginning, we don't really consider the c here, and we know that u is 1 plus v squared, so I'm going to say it's negative half ln of 1 plus v squared. Okay, sorry, so I'm going to take this negative out because I do not want to account for that yet. But yeah, so basically the left side just evaluates to 1 plus v squared plus arctan of v, and that is equal to ln of x plus c. Now usually they should let us just leave it, well yeah, in fact we'll just leave it in this form, but of course when I mean leave it in this form, I mean like we have to substitute v back in. So I'm not gonna, yeah, actually I should do that. So because we know that v is equal to y over x, we could just say negative half ln of 1 plus y squared over x squared plus arctan of y over x. That's equal to ln x plus c. It's technically it's absolute value, yeah. So now what I'm gonna do is I'm gonna because the negative carries over here, I'm gonna add 1 plus y squared over x. Actually, first I'm going to I'm not gonna set this equal to anything here. I'm just gonna worry about this side. So this is equal to negative half ln 1 plus y squared over x squared plus minus arctan y over x. Alright, so and it's equal to ln of x plus c. I'm going to times this side by just 2. So you're going to get negative ln 1 plus y squared over x squared minus 2 arctan y over x equal to, you have to times 2 on this side as well. So that's going to be just 2 ln of x plus, well, 2c is the same thing as c, so we don't really need to look at that. However, we know this is actually, remember, 2 ln of x is the same thing as ln of x squared, so let me just change this to ln of x squared. I'm going to add ln of 1 plus y squared over x squared on both sides, so get negative 2 arctan y over x is equal to, well, if we add 2 ln's, you're just going to be basically the addition of 2 ln's is, it's just the you just multiply it, so you're just going to get x squared times 1 plus y squared over x squared. This is just equal to x squared plus y squared. Alright, so that's going to say ln of x squared plus y squared plus c. Okay. So let's just divide by negative 1 on both sides. Also, yeah, well, I'll show you that after. So arctan of y over x equal to, well, negative 1, so it's going to become ln of 1 over x squared plus y squared plus c. And how they like doing this is because this could just be some ln of some other c. You basically just multiply it, so it actually, this c here becomes c here. So this should be the form it is in. There's a little bit, I think, I'll tell you where, like, to be honest, I think what we did here is correct. But yeah, all the way like in the beginning where we finally got the solution. But I feel like this, of course, simplifies. So let's hope this is right. Yeah, so that is correct. Yeah, I guess they basically did the same strategies off, maybe possibly a little bit different. But that's how you form homogeneous differential equations, and this is just one of the substitution methods you can use. So that's one of them. I did teach Bernoulli, and I'm gonna call that third one. I haven't really gone over obvious, but obvious, it's not, of course, really obvious, but like it's like just kind of like a regular substitution. Usually it's something like you substitute x plus y is equal to b, something like that. 4 is embedded derivatives, so that's like when you have two like terms, their coefficients, or like not the coefficients, like two terms, they have like something where one term has like a multiplier that's like the derivative of another. And then 5 is just the reducible second order, and that has multiple ways you can actually do it, depending on the problem. So yeah, so that's it pretty much. Thank you for